I am studying in class 9. This model is called Ecopods. This model has been created to show how water can be reused in a simple plant system. It demonstrates the natural process of capillary action, where plants draw up and store water in their roots, helping to reduce water wastage. By using such method, we can grow healthy plants while protecting our precious water resources. First, environmental education. It teaches water conservation by showing how rainwater or grey water can be reused and collected. It mimics water cycles such as filtration, absorption, and storage to help people understand ecosystem processes. Second, promoting sustainable living. Show how small urban spaces can support self-sustaining plant system with minimal external resources. It encourages reduced dependence on municipal water supplies. Third, raising awareness of climate change. Climate change in bringing droughts and unpredictable rainfall to many regions. Our water-smart gardening system demonstrates resilience. It can keep plants alive even during dry periods. This inspires people to adopt simple, practical solutions that can make a big difference in facing a global environmental challenge. For the construction of this model, we have used two transparent plastic containers, which in the above container we have soil, pebbles, and piece of fabric used for filtration. If the excess water is stored in the below container, if the water level rises, we can water the plant again through spray nozzle. If the water level rises again, it can be transferred to another pot through a connected pipe. The scientific principles involved in this project are: first, water cycle. Water moves through the environment in stages such as evaporation, condensation, precipitation, infiltration, and transpiration. The planter collects water either from rainfall or manual watering, store it in the reservoir, and gradually release it to the plant roots. This process imitates the natural way water infiltrates the soil and is absorbed by plants. Capillary action. Water can travel up through tiny spaces in soil against gravity due to forces of adhesion and cohesion. Water stored in the reservoir moves upward through the soil to reach the plant roots even when no water is applied from above, ensuring plants remain hydrated. Third, photosynthesis. Plants use sunlight, water, and carbon dioxide to produce glucose for energy and release oxygen into the air. By ensuring a steady water supply, the planter supports healthy plant growth and allows photosynthesis to occur efficiently. Fourth, thermoregulation and insulation. Soil and water help moderate temperature fluctuations through heat absorption and retention. The reservoir helps keep root zones cooler and more stable in temperature, reducing plant stress. Fifth, filtration and natural purification. Soil and gravel can act as natural filters, removing particulates and some impurities from water. As water moves from the reservoir through the soil, it undergoes basic filtration, keeping the plant environment clean. Ecosystem interdependence. In a closed or semi-closed system, organisms and their environment interact in a balanced way. The planter mimics a micro-ecosystem, showing how plants, soil, water, and microorganisms can support each other. Applications or usage of this model. First, home gardening helps grow plants with less water usage. Second, educational tool demonstrates water recycling and plant care in science classroom. Third, sustainable farming encourages water-saving methods in agriculture. Fourth, urban greening, ideal for indoor or balcony gardening where water usage needs to be kept to minimum. Fifth, disaster relief or dry areas, can be adapted for use in areas facing water scarcity or during emergencies when water is limited. 6. It is a smart watering system, eco-friendly method to versatile usage for both indoor and outdoor plants. Thank you.